All right, welcome back. For the next part of the lesson, I want to do 3 example problems with you, but they're tough ones. They're difficult. There's a lot going on in them. Very frustrating. Got to keep track of stuff. Very, very difficult problems here. So for the next part of the lesson, I'd like to do 3 sample problems. All right, here we go. So the first one. How would we find the derivative of y equals the tangent of x squared plus 1 to the 4th power? All right, now just take a look at this for a moment. I'm pretty sure at this point you can see the chain, but can you see the chain inside the chain? What is my outside function? What's my inside function? Now, this is not tangent of this, the whole thing to the 4th power. This is the tangent of this to the 4th power. So what's the outside function? Is it something to the 4th power, or is it tangent? The outside function is tangent. My f of u is going to be the tangent of whatever u is. And the derivative of tangent is secant squared. Now, what's the inside bits that are going on here? All right, so my u is some g of another function, g of v, and that's something to the 4th power. And the derivative is going to be 4 times that to the 3rd power. But then I've got another function inside here, my v. And the v is h of x, x squared plus 1, the inside of the inside of the inside. And of course the derivative here is going to be just 2x. So I'm going to have the derivative of the outside with the inside in it times the derivative of the inside. But the inside is a chain rule, so I'm going to have the derivative of the inside with the inner inside in it times the derivative of the inside of the inside. Oh my goodness, this is getting crazy. All right, so can we write this all down? So I'm going to have secant squared of my u value. What is the u? The u is the inside bit here, is my x squared plus 1. Times the derivative of the inside. The derivative of the inside is going to be 4 times the v, the inside of that, to the 3rd power. Well, what's the inside of that? X squared plus 1. And times the derivative of the inside of that, 2x. So hopefully at this point we're beginning to look at it and it might be making sense. Yeah, I heard you laughing. I've got the derivative of the outside bit with the inside still in it. The derivative of the inside bit. But the inside bit had another inside bit, so the derivative of that. Do you see it now? The derivative of the outside with the inside still in it. Times the derivative of the inside. But the inside had something inside of that times the derivative of that. And if we just kind of clean this up here a little bit, 4 and a 2 and an x, I can pull that out. I've got 8x times, let's see, what have I got? Pull that out. X squared plus 1 cubed. And then I've got the secant squared of x squared plus 1. And we wouldn't do anything more. We would just kind of leave it like that. On a multiple choice test, that's what you would be looking for. They wouldn't ask you to do much more simplifying beyond that. And hopefully if you got this part, careful in getting that part, you'll be able to pick that out of the lineup, out of a multiple choice. Tough one. Tough one. Let's look at another tough one. We never want to be afraid of the tough stuff and kind of hit it straight on here. So suppose I have y equals x cubed times the square root of x squared plus 1. All right, so the first thing that you should notice here is I'm going to have product rule. I've got this function and that function. So just if you think about them as the product of 2 functions, I've got the x cubed and the square root of x squared plus 1. So remember, first times the derivative of the second plus the second times the derivative of the first. And this one's easy to do the derivative of. This one, not so much. I'm going to have a chain rule inside here. I've got a chain rule inside of my product. All right, so let's break it down into my u's and ones, my different parts that are going on here. Let me see if I can break it down a little bit more. In part 1 of this, I've got my my f of x is x cubed, and the derivative of f of x is 3x squared. Part 2 of this, I've got my g of x, the other function, which is the square root of x squared plus 1, and the derivative of g of x, because remember, I'm going to take the first times the derivative of the second, plus the second times the derivative of the first. Here comes the chain. Here comes the part that's a little bit more difficult, my g of x. How am I going to deal with that? I'm going to call it u, and the outside part of this is going to be x, or u to the 1/2 power, right? Square root. And of course, the derivative of the outside bit is 1/2 u to the negative 1/2. The inside function is going to be the x squared plus 1. And the derivative of the inside function is going to be 2x. So, careful. We're going to do, now everything's up here. Everything we need is up here. It's going to be the first times the derivative of the second plus the second times the derivative of the first. Here's the first. Here's the derivative of the first. Here's the second. And here's going to be the derivative of the second when we plug that in. All right, so putting it all together, let's see what happens. So we're going to have y prime, my derivative is going to be the first, x cubed, times the derivative of the second. What's the derivative of the second? 1/2 times u to the negative 1. What is u here? It's the x squared plus 1 times x squared plus 1 to the negative 1/2 power times the derivative of 2x plus, so here's the first times the derivative of the second plus, I'm going to write it over here, I'm kind of running into myself here, plus the second, which is the square root of x squared plus 1 times the derivative of the first, 3x squared. I don't know if there's much simplifying we can do here. Let's see if we can make this thing look a little bit prettier. Y prime equals, what have I got going on here? I've got the x to the cube. This is going to be in the denominator. That's going to be in the denominator. So I'm going to have x cubed over 2 times the square root of x squared plus 1. Oh, I forgot this 2x, didn't I? The 2x should be out here. So make that, if I bring the 2x over here, that's going to be 2, and x to the 4th. Oh, I can simplify those 2's. Plus, let's see, what's this going to be? 3x squared times the square root of x squared plus 1. And I could simplify those 2's there. So x to the 4th over the square root of x squared plus 1 plus 3x squared times the square root of x squared plus 1. Another tough one. And this one had a product and a chain inside the product. Taking the derivative of the second part required a chain rule. All right, one more tough example here, and then that'll be it for today. This is a 2-day lesson, so when we come back for the next lesson, we'll look at more of these. So f of x equals, so 3, open parentheses, 3 plus, open parentheses, x cubed minus 2x to the 5th power, and then this whole thing to the 8th power. All right, so take a look at this for a moment, and what do you see? There's no product rules here, but I've got an outside function, which is this whole thing to the 8th power. And the derivative is just going to be 8 times this to the 7th power. And then I have to do the derivative of the stuff that's under my hand. The derivative of this, well, the derivative of 3 is just going to disappear. The derivative of this, I've got another chain. It's going to be 5 times whatever this is to the 4th power times the derivative of this. And the derivative of this will be 3x squared minus 2. Are you seeing it? Usually right around now, students are seeing it. I've got the outside something to the 8th power, so 8 times this to the 7th, times the derivative of this. Well, that disappears. And then I've got this to the 5th would be 5 times this to the 4th power, times the derivative of this, which is going to be 3x squared minus 2. Can you do it all in one go? So instead of using all the u's and the v's, let's take a look at this. So I'm going to say that this is 8 times all of that stuff to the 7th power. So 8 times that to the 7th power times the derivative of the inside bit. Well, the derivative of 3 is going to disappear. What am I going to have left? Really just focusing on this. 5 times that to the 4th power. 5 times x cubed minus 2x to the 4th power times the derivative of that inside bit. 3x squared minus 2. So kind of there it is, all in one go. So 8 times this whole thing to the 7th power. The derivative of the whole thing is 4 times that to the, or 5 times that to the 4th power, times the derivative of that, which is this. So just take a look at this. See if this makes sense now. Are you beginning to see it? And the whole u and v thing is just a way of kind of breaking it up. What is the outside function? What's the inside function? What's the derivative of the outside? What's the derivative of the inside? Just a way of organizing it and making sure that everything's in the right place. And if you can see it like this and just do this chain within a chain without doing all that extra stuff, that's fine. That's absolutely fine. All right, so those are the only examples I wanted to do today. Go home, look at the homework, 3.5. We've still got a whole nother day doing the chain rule, and there's some other things that we need to talk about, not just with the chain rule, but some other examples here. And when we come back for the next class, we'll have 2 more videos about the chain rule. It does get easier. I promise you, it does get easier. All right, guys, good luck. I'll talk to you again soon.